Tuesday is the last day we meet at 8:30. Next week, we don't meet on Monday for class at all. And next Wednesday is just an office hour. Okay, we put it fine. So we want to plug in these numbers, make sure we plug them in correctly. So first one. And we're going to round to 4 decimal places. So let's see. I haven't I got it. Okay. Let me see if I can get that to show just a little bit better on the screen. Page 5.37. We punch that in first. And we're going to raise it to the 2.1. I can't see that. I think you can move over here. But these would be the freebies. This is just an actual question. 5.37. The exponent button, this is not going to help you see what I'm doing. To the, and that's on this calculator. The other calculators are different. Make sure you know how to use it. To the 2.1. Then you hit enter. Now 4 decimal places. You need to know what the 5th decimal place is so you can make your decision about the 4th. So 1, 2, 3, there's 4 decimal places. This is the 4 round to 0 up to a 1 or leave it at 0. Do I have to write the 0? Yes or no? Yes. Yes. If I don't write the 0, I don't have 4 decimal places. Okay. So the 4 decimal places, this is approximately 34.1150. If this were a multiple choice test, and you know you're raising to 5, something bigger than 5, to a number bigger than 2. And there's choices where one answer is in between 25 and in between 50. And the other choices are smaller than 25 or like 80. You can do this problem without everything I did. 5 to the 2.1, A is 10. All right, let's go with this. 5 times 2.1 would be 10.5. B, 20.5. C, 25.84 for some reason. D, 34.12. And then D, or E, 60.48. And you were just no calculator. How do I do something like that to a 2.1 power? Well, shoot, it's certainly bigger than 5 to a power bigger than 2. It's not going to be that close to a 25. I'm going to just look at it as a 53 to a second. It's not going to be around 25. So the only thing they're potting, it's not going to be a 60 either to get something to a 60. 6 squared is 36. And that's not even close to a 6. It's not even close to a 6 to a 2.1, 5 to a 2.1. It's not even going to be close to a 6 squared. So there's ways to do these multiple choice questions when you're looking at them and you don't have a calculator because your choices, it's meant to be, are you paying attention to the question? Not whether or not you can actually do the calculation without a calculator. Do you make sense out of that, this number raised to that power has to be within a certain range. For instance, this is going to do what? It's going to flip it. So this is going to be 1 over 0.138 to the positive 5.2, which is, when you raise a decimal to a power, it makes it a much smaller decimal with lots of decimal places. But 1 divided by that makes it a huge number. I should get a huge number out of it. This better equal a huge number. When you do a decimal in the denominator, like 1 over 0.1, how many dimes go into a dollar? 10. How many pennies, 0.01, go into a dollar? 100. How many thousands are in a dollar? 1 divided by 1,000. 1,000. So the bigger the more decimal you have in the denominator, the bigger the overall number is. When I raise this, when I flip it, and it becomes a much bigger decimal, because if I have 0.1 squared, that means 1/10 squared, which means it's 100. So 0.1 squared is 0.01. It becomes a much smaller number. So when I raise this to a positive 5.2, this is going to be a much smaller number. Which means when I flip it, it's going to be a huge number. So if I just punch it in, and if I just punch things in and not have a clue as to what's happening, then I'm a slave to a calculator and I don't know what's supposed to happen. And I don't know what is, if I punch it in wrong, I'll just write it down because I don't have a clue. If I punch it in wrong, you should always have a clue. So I prefer parentheses. I just make a little paranoid. 0.138. Close the parentheses to the, and I prefer parentheses again. Negative 5.2. Again, be paranoid, especially with these. I forgot parentheses. $39,691. So the fourth decimal place, which is the 3, is the 9 going to round it up to a 4 or even a 3? 4. So 29,691.2684. Any question about that? Pi to the square root of 3. When I type in pi to the square root of 3, so I got to hit the pi button, then I got to hit the exponent button, and then I got to type in square root of 3. But here's the pi button. Pi is right above the exponent button. The square root button's over here right above the square button. The pi button, you have to hit second and then pi. The square root button, you have to hit second and then hit the square root button. You don't type in 3.14. You want to use the actual number pi. So pi, and then to the, and then second square root of 3 and close the parentheses. There it is. Type in pi to the square root of 3. And 10. Now, let's think about how much is pi approximately?
3.14.
We don't say 14. 3.14. It's a little bit bigger than 3. The square root of 3 is approximately 1.732. So it's a little bit more than 3. It's 3.14 to about 1.732. So a 3 raised to almost a 2. So it should be in the neighborhood of what?
9.
If I get 27, positive. If I get a negative number, definitely. So 4 decimal places, 1, 2, 3, 4. Is the 5 rounding up or staying in 5? Staying in 5. You'd be surprised how many, I mean, at every level, the rounding is rough. Either they don't round, don't read the directions, don't listen to me, or they don't round. So 7.2625. So now the exact value of e to the 4th. So the only place you're going to get an exact e is right here above the natural log button. So there's your e to the x. And the only way to activate that e to the x, you got to go second, and then you hit that e to the x button. Second. And then natural log, which is your e button now after you hit second. So e to what power? We'd like a 4, please. Close that parentheses, e to the 4th. Now remember, e is approximately 2.7. E is approximately 2.71828. So e to the 4th is a little bit bigger than 2.5, not 3 though. To the 4th. 2 to the 4th is equal to 16. 2 to the 5th is 64. Okay, that doesn't really help a whole lot, but that's close to 3. 3 to the 3rd is 27. 3 to the 4th is 81. So we know it's smaller than 3 to the 4th. We know it's got to be bigger than 2 to the 4th. It's got to be less than 2 to the 5th. Have a range of numbers in your head where it should land. Because if I see something like 2 times 4, which is 8, 3 times 4, which is 12, ignore them. Okay? 59.5, not 54. Again, right now, 54.5982. Any question there? Calculators are, we got batteries ready to go for this week and next week. Okay. Five and 4 get mixed up. On 4, you have to go second and then use e to the 4th. But on 5, you're just taking the natural log of it. So you're using the same button, but this one over here, you got to go second because you want to do e to that power. Over here, you just taking the natural log of the 3.14. So you don't use second. You're just gonna hit that natural log button, and then you type in your 3.14, and then you hit enter. Log 3.14. Oh, enter. Gives us 4 decimal places. Down to 2 there, so 1.144.
Did you put the one first?
What's that? Oh, 7. Because in my head, when I was thinking about what I was going to put, in my head, I'm on 4, because when I was on 4. I wrote 7 when I actually wrote it down. So when I was doing this problem, I didn't wrote it. My mind was sold about 30 minutes ago. It's really bad when you're reaching an age where your mind, you start some time shift. It does change quite a bit. So that is going to round 1.1537. Okay. Log base 5 of freedom. Log base 5 of freedom. There is no log base 5 button. There is, we got log base 10, we have log base E. Those are the only 2 logarithm buttons we have. No base 5. So you have to use the change of base rule. Whether to convert that into log base 10 or change it into a log base E. Natural log. So on the review sheets and the notes I sent out to you. Your change of base rule right here. If you have a log base V of X and you want to change it into a different log base A. Log base B of X, and I don't want base B, I want a different base. I can convert this into any other base that I want, log base A of X divided by log base A of the old base B. I can rewrite it in terms of another base. I can change it into a log base 12, log base 4, log base 27, log base E, log base 10, log base pi, log base anywhere. We would want to convert it into either base 10 or base E because that's what the calculator does. If I use log base 10, so they would be log base 10s on the top and bottom, the common log of X, what's inside, divided by the common log of the old base. If you want to convert it into natural log, then it's the natural log of what's inside, divided by the natural log of the old base. You want to rewrite it first and then punch it in. And the reason why this works, in case you don't remember those formulas, if you had to solve this, what is log base 5 of 300? I would do it like this. I don't know, let's call it X. And then rewrite it Blank to the blank equals blank. What is it? How do we translate that? Blank to the blank equals blank. When I convert it into an exponent form. Gotta practice your mod, because this is simple questions to get on your test, because all you gotta do is convert this into exponential form. Blank to the blank equals blank. Good, so the base is base of the logarithm to the across, which is x equal what's inside 300. So now we're just trying to solve an equation that's an exponential equation. And we want to undo the exponent, and logarithm undo the exponent. So now you just take a logarithm of both sides that you like. Do you want to take log base 10 or log natural log? You have to choose. Don't always solve it. Pick one. Natural? Yeah. So you take the natural log of both sides, and then it becomes that Price is Right rule. Come on down. This is now multiplication. Natural log x times the natural log of 5 equals the natural log of 300. And because it's now multiplication, you just divide. Divide both sides by the natural log of 5. So x is equal to the natural log of 300 divided by the natural log of 5, which is the change of base rule if I just use the change of base rule right here. So if you don't remember the change of base rule, base to the across equals slope inside, which is what I was telling you all last week and week and a half. That will save you behind all the time. Convert it. Natural log of what's inside, well, what's inside is a 300. So the natural log of that 300 divided by the natural log of the old base is 5, the natural log of 5. I can just convert it, or if I don't know it, I'll write it as let it equal x, convert it to an exponent, then take the natural log of both sides. Because I've been saying that base to the across equals what's inside forever and over again. So this is what you punch in. So natural log of 300, natural log 300 divided by, close that parentheses, so close off that natural log of 300 divided by the natural log of 5. Close that on. So one divided by the other. So this is equal to 3.5439. Now look, 3.543959,311. You're rounding to 4 decimal places. Well, here's the 4th decimal place. The 4th decimal place is that 9. That 5, is it round the 9 up or leave it at 9? I'm going to round it up. So what if I round this 9 up, what's going to happen? So it's going to increase the 3 to a what? 4. So this is going to be like, think of it as a 39. What would the 39 increase into? 40. So this would be 3.544. Do I have to put the 0? Yes, because I need 4 decimal places. So you have to rewrite it into a base that you can plug in, and then plug it in and simple or wrap it. You need the base one. Number 7. All it says is log 0.0946. Well, you can't do it unless you know the base. Now it's LOG, and if there's no base number written, then what base is base 10? That's base 10. If there's no number written as the base of that logarithm, it's a base 10. And even here, when you see the LOG on the calculator, right above it is 10 to the x. That's the common log. So all we're doing is taking the common log of 0.0946. We get negative 1, 2, 3, 4, negative 1.0241. Now number 8, I changed my mind. I don't want a decimal. The number 8, I don't want the exact value. No decimal. And you should be done with that in about, well, we're now. Or at least you should be done with it by now. Okay, with statements. Why aren't you done with it? I'm waiting.
4.555.
Did it say decimal or no decimal? Nope. Why aren't we done? It's the freebie. This is the biggest freebie you're going to get from me. I keep saying all these freebies. Yeah, fun. But that doesn't mean you don't have to study. What kind of logarithm is it? What's the base of the natural logarithm? E. What's inside? What are we trying to get the natural logarithm of? What are we taking the natural logarithm of? Right in front of you, right up here. Up here, up here, here.
I plus 30.
No, no. What's in there?
E.
What?
E.
E to the what?
I plus 30.
Right. So first of all, natural logarithm does not have an E show. There's an E down here. This E is inside the logarithm. It's not the base. This is not the base. When we write natural log right here, we don't write E, but this logarithm is base E. We know there's an E down here. This E is inside the logarithm. This is the exponent. So what number 8 is this rule. Natural log of e to the x is just x. Log base b of b to the x is just x. If I take log base b of an exponent base b, if the bases are the same, they undo each other, you just get the power. The base of the natural logarithm is an e. Inside is an exponential function, base e. The base of the natural log is an e. This thing down there somewhere. And inside you have an exponent base e. Since the bases are the same, they undo each other and you just get that power. So this is just I plus square root 2. So it's like, if you know your properties, it's the quickest problem you're gonna do. But you gotta know the properties. And that's the whole point of logarithm, just you have these properties that make things move so much quicker, so much easier to handle. But if you don't speak that language, if you're not taking the time, and I know it's a lot, but if you don't take the time to see some of these, hey, these bases are the same, their job is to undo each other. So I need to start recognizing these things. It's like knowing your vocabulary when you got to take that language test. You don't have that vocabulary down, and these properties are your vocabulary. And it's right here on the backside of the balance sheet, no, backside of the side of the exponent. On the review sheet, I believe I'll put it on as a third page of the review. Rules 3 and 4. Log base b of b to the x, since the bases are the same, they do each other, which is that power. Natural log of e to the x, the natural log has a built-in base e, and then you're taking e to the x, natural log of an e to the x. So the base of the natural log is the same as the base of what's inside. You just take the x. Likewise, if it's an exponential function, b to log base b. So the base of the exponent is the same as the exponent's logarithm base b. The bases are the same, they undo each other. The base of the exponent is e raised to a log, natural logarithm. So that's the base e. So e, natural log, base e, bases are the same, they undo each other. If you have 10, if you have the common log of 10 to the fifth, the answer is just what?
5.
It's just 5. Because that's inside the logarithm. How do I know? Because I'm not writing it like this. I'm not writing it down here as a subscript. It's a common log in here, 10 to the fifth. And if it's not clear, come up and ask. Make sure you can make the calculator sing and dance. Make sure you know how to punch things in. Make sure you don't butt dial stuff into your calculator and you get the wrong number. Okay. It's your turn. What do you want to see?
Programmable rate,
Which one?
H16, no, it's pages,
The 60 page one?
yeah,
For final focus,
yeah.
which number?
101, 101.
So on these questions, on your review and on your test, they will be multiple choice. Well, my body just, and you see James Gunn version of the Suicide Squad? Yes. Nathan Fillion had a character, I don't know, he was like DMK or something like that. It's like, anyway, he could basically, he could control parts of his arms would fly out. And then it was really dumb. It's like the old DC characters that came out in 1950. And so his arms fly out and his arms go floating towards you. Right now, my shoulders are ready to just fly. I need a shoulder, both shoulder pieces. Now, think of the about it. You know, when I was a kid in the 70s, I saw the $6 million man. I know that they have that technology, so they're keeping it themselves. What about their teachers? Okay, so the rule or the three rules. Supposed to do a $6 million man with Marky Mark. I think it's really like this. If you have multiplication, you can separate the logarithm of multiplication with addition. When you have division, you can separate division, log base b of the numerator minus log base b of the denominator. And if you have exponents, come on down, you can write it as a multiplication problem. We have all three. We have division. In the numerator, you have multiplication. And in the numerator, you also have some exponents. So I'm going to actually do this problem as if I didn't have multiple choice. Then I'll show you how to do it where you have multiple choice, and you probably want to do it this way when you do the test. So the first thing is, I'm going to separate the division. So it's log base 5 of x to the 9th times y to the 8th, the numerator, and then you're subtracting log base 5 of the 2. Now, the good news is there's nothing else you can do with that log base 5 of 2. Because there's no power, there's nothing else added, that's done. But the first one, you have multiplication that you can separate. But when I've done this problem before, I would get students stop right there so they don't finish it. They go, they separate the division, go, that's it, I'm good, I'm tired. Move lie down. But there's so much more you need to do. You can separate multiplication with addition. So this is log base 5 of x to the 9th plus log base 5 of y to the 8th, and you still have that log base 5 of the 2. You separate the multiplication with addition. So the x to the 9th and the y to the 8th. And since those two logarithms have exponents, we now bring those down in front as multiplications. So it's 9 times. So it's going to be, bring that down, 9 times the log base 5 of x plus 8 times the log base 5 of y minus the log base 5 of the 2. So this is log base 5 of x times 8 times log base 5 of y. No, not multiplied. This is log base 5 of x. The whole thing is to the 9. It's not the whole thing to the 9. It was just an x to the 9. 9 times log base 5 of x plus 8 times log base 5 of y minus there it is. Okay? So C. And if it wasn't a multiple choice, that would be your final answer. You can't do anything more than that. Because it is multiple choice. You still need to know the rules. So I'm going to do process elimination. I know that we separate division with subtraction. So I'm going to be looking for some subtraction. And it's this divided by. So the first thing I'm seeing is you have multiplication up here. This one times this one, the 8. The 9 times log base 5 of the x and 8 times log base 5 of the y. But you know you're going to separate multiplication with addition. They're just multiplying those two together, and then they're just separating this and divide by the other one. That doesn't even come close to any of the rules of logarithms, so it can't be A. This one, instead of x to the 9th, they're raising the entire logarithm to the 9th. So that changes things. That's a completely different question. And you also have an idea that when you have x to the 9th, you're probably going to want to bring that 9 down in front and make it 9 times something. That's not down in front, first of all, and it's a different question because you're raising the logarithm to the 9th, not x to the 9th. So it's not B. Here you have 9 times log base 5x. That looks more like what we're doing. Plus, that's multiplication, so it's probably going to be plus. 8 times, well, there's 8 on the y, and then minus log base, the denominator should be subtraction. So this is looking good. And just always check the last one. That's the same, but it says plus the denominator. Well, the denominator is going to be subtraction, not addition. So you can do that problem without doing the problem. Okay. And I was just talking you through all of it. And it's going to be a multiple choice on that when you finish. I'll tell you how many of each kind we have to attempt. But so put this one right. They want you to put this one back together and write it as a single logarithm. What's in between? Addition. Well, what would have been over here where it got split up with addition? Well, addition got split up because back over here, it was multiplied together. So when you're looking at the answers, these two go back together as addition. Well, that doesn't seem right. I have addition in the first place, so then I can just separate the two with addition. That really doesn't seem right. Log base 3 of m times n, you're supposed to make multiplication be split up with addition. That looks good. just multiply the two logarithms together. I don't remember ever seeing anything in the notes that looked like that. And that's what you gotta kind of recall. Maybe you don't know it by heart, but you should at least recognize, I've never seen that. And this is division. Well, division, should be subtraction. It shouldn't be that. And then if you do those multiple choices where those properties of logarithms are there, and you had some questions about what to use when you were doing other problems, maybe that'll jog your memory to get those other problems done. When you're doing a multiple choice, especially in math, check the answers. Sometimes you can just do the problem by looking at the answers and process of elimination. I highly recommend this when it comes to your finding. Not everything, but it doesn't hurt. You can eliminate a lot of possible answers. Maybe you're just left with one where you don't have to actually do the question. But if you don't practice it, you have a final focus. You don't practice it before next Wednesday. Trying to do it on the fly next Wednesday is not going to help. Anything else?
86.
Which one?
86. Sorry.
86.
Yeah.
Okay. This one, if I were to ask this one, I would want exact value. So I would expect you to be able to do this without a calculator. In order to do this question, it's an exponential function. So you should be able to solve it by getting the same base on both sides. 4 to the negative x equals 1 over 16. So we need the common base. So 4 and 16 are both powers of who? They're both powers of 4. They're also both powers of 2, so you could also use 2. But 4 to the first is 4. And 16 is 4 squared. So I'm going to convert these into 4. I don't have to change the left side. 4 be a negative x, that's fine. But this is 1 over 4 to the second. Now, it's not ready yet, because it doesn't work unless I have 4 to the x equals 4 to the y, where the x and y can now be written equal to each other. So the 4's have to be both in the numerator. So I need this one to go up here so I can have 4 to the negative x equal 4 to the something. So if I was going to flip that 4 squared upstairs, what happens?
It's -2.
Exactly. This is now 4 to the negative 2. So now I can go under here. U negative x are going to equal u negative 2 divided by negative 1. And x has to be a positive 2. And if I was just checking numbers, plug in 2, 4 to the negative 2 is 1 over 4 squared is 116. Plug it in half. 4 to the negative 1/2 is 1 over 4 to the 1/2, which is 1 over square root of those, which is 1/2. And I'm not taking the calculator, which you can always check it on the calculator. But that's At 10 o'clock. One more. Figure it out before 10. Figure it out before 10 o'clock. Let's do that. Come up with some good ones or it's gonna be a long hour and 50 minutes.